All right, welcome to part 2 for our day 1 of electric currents. So in the previous video, we looked at batteries. We didn't get into a lot of the nitty-gritty information about batteries, but we briefly went over them. And we'll see them again once we start building into circuits, but we need a couple more ideas first before we can do that. And one of those ideas we need to discuss is the electric current. Okay, so here we have the definition for current. It's just a flow of charge. So if you have any amount of charge and it is flowing or it's moving, you've created an electric current. So here we're talking about the actual charges moving. We're not talking about what it's going to be useful for at this time. Like I said, we're going to build up to circuits. But today we're just going to start laying the groundwork of a lot of terminology that's going to be used. So here we have the equation for the electric current. I is going to represent the current. It's going to be equal to delta Q, so the amount of charge divided by the change in time. So if we think about our SI units, charge is measured in coulombs, and the SI unit for time is in seconds. So our SI unit for charge is coulombs per second. And we like to not have to write out coulombs per second. It's a little annoying, especially since we might not be measuring in seconds. Counting an individual charge is going to be hard. So instead, a lot of the times we use amperes or amps. So when you see a capital A, we're going to be referring to it as amps. Amperes is the same thing, and it is a coulomb per second. So with electric current, a lot of the times we are going to be focusing on it in terms of circuits. And so in order to have a circuit, there's a couple of different types we have. We are going to be primarily focusing on something that is known as a complete circuit, which is a closed loop. So we have a continuous conducting path. And the reason we want this nice continuous conducting path is we can actually sit there and measure the current for a longer period of time. It's not going to be some really short, the charge is moved, we're done type thing. We can continuously measure the charges through some amount of time. So typically in the circuits that we are going to be dealing with, we have some type of source. We are primarily going to be looking at battery sources. However, in a couple of cases, we will be looking at a capacitor source. So we have some sort of source for our charge. And we can have a couple different types of components. We're going to be focusing on these things called capacitors and resistors, but there are thousands of other types of things you can put in your circuit as well. So we're going to be setting the base. So when we get into circuits in more detail, we're going to be focusing on the basics of it because circuits can get super complicated super fast. An open circuit is just going to have a break in the circuit. So you're not going to have this continual flow of electrons because there's literally a space where the electrons are not going to be able to flow. So for example, if you have a switch and you have it in the off position, you open your circuit. So yeah, usually in this class it's going to be a switch. There are a couple of other things you can do in order to have an open circuit. So some of what we'll be seeing as we start to build into circuits moving forward, again, not necessarily today, or in fact, not necessarily today, I mean not today, is we want some sort of way to indicate what's happening in our circuit in order to represent how our electric current is going to behave as we move through our circuit. I'm going to be sticking to textbook notation when going through and doing anything circuit notation. However, I do just want to clear up that there are other notations out there. Physics tries to stick to one of them, even though there are a couple of different things that'll pop up that might be different from textbook to textbook. So I just want to cover some of the symbols. Again, we're not going to be using these today. We're going to build into it a little bit later, but I just want to show you guys, so if you start looking at sources, you understand kind of what they're representing. So these are the symbols for a battery. So you have two different ways. So you have a long line, short line, or you just have long and short line. The short line is going to correspond to your negative electrode, and the long line corresponds to your positive electrode. Our textbook is going to be using the single set of lines in order to express a battery. So that is what our textbook is going to be using. The other thing that you might see in a circuit, we're probably not going to see very many of these, but a lot of, especially more modern homes, now it's a requirement, they have a ground in them. So excess electrons can then flow into the earth. And so these symbols down here correspond to the different symbols for a ground. Our textbook is going to be using this left symbol here. So again, these symbols are just going to be what you might see in circuits, and we'll build into a couple other different ones as well. But we are going to start seeing some images of circuits as we move forward with the rest of the chapter, because we want to represent them as they are seen in a way. So one last thing about electric currents is, we've changed a lot since the discovery of electricity. And so the original kind of idea for electricity was that the positive charges moved, and that's what carried a current. We now know better related to the size of our protons and our electrons. Electrons are way smaller than protons, and because of how an atom is set up, the electrons are going to be able to move in comparison to our positive charges. So now we know it's the negative charges, it's the electrons that cause an electric current, not the positive charges. However, for some dumb reason, we've decided, we being physics people, I didn't decide this, believe me, have decided that this is going to be a place where tradition for some reason doesn't die. And the conventional current, which is the current we're going to be focusing on a lot in this class, is the direction of the, in quotes here, positive moving charges. So the conventional current is the traditional current, and it's the one where the positive charges move. The electron current is the real current. It is explaining reality. It is the direction of the moving electrons. So depending on what term you see, if you see conventional, we are going to be using the positive charges. If you see electron current, we're going to be using the electron current. Now again, in a majority of situations, we are going to be using the conventional current. This is just tragically how it is. We know it's wrong when it comes to accurately describing what's happening, but it is still what we use. So this image here is kind of a schematic for the different ways that current flows. So here we have our battery. So we have our positive electrode and our negative electrode. It's in a circuit that is attached to some device that we don't know what it is. So you'll see that we have the conventional current. It is flowing from the left up to the right, down, back towards the battery. So it is flowing in a clockwise direction. That is the conventional current. So that is the direction of the positive moving charges. So it's going to go around this way. Just make that one line. So it's going to move all the way around and then back into the battery at the negative electrode. If we wanted to look at the actual flow of charge, right, we want to look at the electric current that is actually happening, we would start at the negative electrode of our battery, and we're actually going to move around counterclockwise until we enter the positive electrode. And it's this weird, again, I don't know why physics has decided to keep this traditional, it just has. But we'll talk about kind of what we end up seeing with these two different ideas. Just understand that they just flow in opposite directions. That is the only difference between them. Conventional is going to flow one way. The electron flow, or the electron current, is going to be the exact opposite direction. And there'll be a couple of different ways we can see that moving forward when we get into circuits, but again, that's not our problem today. So this is going to wrap it up for the second video. In the third video, we're going to be doing quite a few examples, and we're going to be looking at this thing called resistivity.